So this will act as a PN junction here, and emitter is terminal is take it out here. So between the two ends of this N-type bar, we are calling this as a base 2, and this is called as a base 1 and base 2. Between the base 1 and base 2, we are applying a voltage of VBB. VBB voltage applied, right? So this VBB voltage is an application here. The entire bar is we are dividing into the two resistors, right? One is called as from base 2 to at this center point, emitter junction point, is called as RB2, and from emitter junction to the base 1 terminal, we are calling as a resistance called as RB1. RB1, RB2. Two resistors are separated here, and in between an emitter is connected. So emitter is a P-type junction that can be replaced by a PN diode. See here, the equivalent diagram. Here it is, column. So a diode D is used here. This will act as an emitter junction, showing as an emitter junction, and these are two resistors. And the total resistance with I is equal to 0. If there is no emitter current, I is equal to 0 అయినప్పుడు the entire resistance is called as a inter-base resistance called as RBB. Resistance base to base, RBB. Resistance base to base is equal to RB1 plus RB2. RB1 plus RB2. Right? This is the equivalent circuit, and intrinsic resistance is intrinsic resistance under RBB, inter-base resistance, is RB2 plus RB1. Right? So I want to, when I is not equal to 0 here, some voltage is applied, or some VBB, base to base voltage is applied. Here you see the circuit diagram, construction diagram, VBB or VBB is applied. So there exists a voltage drop across RB1 and RB2, right? So what I am finding, I want to find out the voltage drop across RB1. I need to find out the RB1 voltage. So our drop across RB1 I am calling as a VRB1, which is equal to applied voltage VBB into where I am measuring RB1 across RB1 by RB1 plus RB2. So RB1 by RB1 plus RB2, this call I am replaced by a constant called as a eta. So eta is equal to RB1 by RB1 plus RB2, right? Which is equal to RB1 by RBB. So eta is called as the intrinsic standoff ratio. Intrinsic standoff ratio. So voltage across VRB1 is equal to eta into VBB. Eta into VBB. So this is the things we have observed yesterday, right? Now we have to go through the operation of this one, right? Why we are measuring the voltage across this? Why not here, right? All these things we have to go through here. So coming to the operation, this voltage, what I am calling as VRP1 is equal to VBB eta into VB. This I am calling as a some VA. I am calling as VA. VA is the voltage which is existing across the RB1. That voltage is VA. Right? So when VA, if the conditions are this voltage is VA. Right? The voltage across this is VA. So first condition is when VE and VA. So VBB is a fixed voltage which is applied across the base 2 and base 1. That is happened. Because of this voltage, VBB voltage, there existing a VA voltage is existing here, right? VA voltage is existing here. Because of VBB, there is existing a VA voltage across RB1, right? Now I am applying the voltage VE. You put in VE voltage apply. So I have to go through the three types of conditions here. Three types of conditions. First condition is I draw here. So first condition is when VE is less than VA. So drop across the voltage, RB1 voltage is more compared to the VA. So in that case, the PN junction is reverse bias, right? Is it not? Because VA is a voltage applied onto the PN junction. This is the PN junction. This is the N region. So there existing a PN junction. So to this PN junction, the voltage applied here VA is in the reverse. Will make this junction into the reverse bias. Will make this junction into the reverse bias. So there is no question of any emitter current flow. So IE is not flowing. I is not E is equal to 0. So when I is equal to 0 means I can say that UJT is off. UJT is off. That is the first condition. So first condition ఏంటి VE లేకుండా VA మాత్రమే ఉంది అనుకుంటే అప్పుడు VA voltage is applying is forcing to make this PN junction is reverse bias. Because VA voltage means this is the positive voltage, this is the negative voltage. Be careful. Positive and negative means this positive voltage is given to the N region, right? So and automatically this is connected to the 0, negative. So this becomes a PN junction is reverse bias. This is the first condition. Next, second case. The second situation, if VE is greater than. Now I apply the voltage VE. This VE is greater than VA. Because it is a PN junction, there existing a voltage called as cut-in voltage, right? That is plus V gamma. The two voltages. So VE external emitter voltage is more than the cut-in voltage of this plus this voltage. The two voltages ki ఎక్కువగా ఉందనుకోండి, more than this voltage. Then I can say that the PN junction is in forward bias. So there existing a current IE. IE is there and the UJT is on. Or fives. UJT fives around. UJT fire in meaning ఏంటి? UJT is on state. So when IE is there, when VE is greater than VA means the voltage drop across apply voltage VE is greater than the drop across the R1. అయిందంటే then I can say that UJT is on state. When it is on means then there exists the emitter current IE is flowing, right? So in this situation, this increases charge concentration between the emitter and base. ఇక్కడ concentration, charge concentration పెరుగుతుంది because it is forward bias. Generally forward bias అంటే ఏమవుతుంది, all the charge carriers are moving in all directions, right? Diffused. The holes are diffused here, right? Electrons are moving in this direction, holes are moving in this direction. So ఈ holes అని ఎలా అవుతున్నాయి, ఇలా diffuse అయిపోతున్నాయి, ఇలా diffuse అవుతున్నాయి, ఇలా diffuse అవుతున్నాయి. So ఇలా diffuse అయిన holes అని ఏమవుతున్నాయి, diffused move in this direction because the base is also a positive terminal. So a positive concentration is present at base 2. This holes will reflect. This holes is reflect because of this positive charges, similar charge. Holes are positive charges, and this terminal is also positive charge. So similar polarities will repel each other. So the holes which are repelled from this base 2 and are moving towards the base 1 region, towards the base 1 region, right? That's why the barrier is moving along this and it comes to like this. So the carrier is moving like this and comes to. So all these are moving and collecting at the base 1. So that's why this arrow mark in the FET, this arrow mark is FET, direction of current is showing here is the symbol here is the symbolic here is it is moving, emitter current is moving towards the base 1, not base 2. The holes are diffused and move towards, some holes are moved towards the base 2, but current is not flowing like this, is it not? They are repelled from the base 2 and are reaching to the base 1 terminal. So entire current, entire charge particles which are diffused or which are diffused here from P region, they are reaching into the base 1 region only, base 1 terminal only. So the entire current IE is flowing from emitter to the base 1 only, not to the base 2. That's why this arrow mark is showing here, showing towards the base 1. ఇది ఈ రకమైన ఫెసిలిటీ మనకు అక్కడ లేదు, FET లో లేదు, జస్ట్ షోయింగ్ సింప్లీ an arrow mark అంతే. బట్ ఇక్కడ UJT లో వీఆర్ బెండింగ్ దిస్ arrow mark and showing towards the base 1. That is the difference. You have to remember, right? So while moving this charge density from emitter to base 1 by repel the base 2, the resistance RB1 goes on decreases. అంతే కదా? As the charge carriers are more and more or increased here, more and more or increased here, current is increases. So automatically when current is increasing, indicating that the drop across this also decreases. So the resistance RB1 decreases with increasing the IE. ఈ ఐ ఎలా వచ్చింది? ఇలా వచ్చింది. ఇలా వస్తాయి కొన్ని పార్టికల్స్, ఇలా వస్తాయి కొన్ని పార్టికల్స్, రైట్? is all constituting a current IE. So when IE is more and more, IE's current is increases, the resistance of RB1 is decreases, right? Therefore, voltage drop VE between E and base 1 is also decreases, right? Voltage drop across voltage VE, voltage VE between E and base 1 decreases because of increasing in the decreasing in the resistance. అంతే కదా? రెసిస్టెన్స్ తగ్గిపోతుంది కాబట్టి ఆటోమేటిక్గా ఇక్కడ వోల్టేజ్ డ్రాప్ కూడా తగ్గిపోతుంది. బేస్ ఎమిటర్ నుంచి బేస్ వచ్చే వోల్టేజ్ ఇస్ విజి, రైట్? సో దిస్ ఫినామినన్ ఇక్కడ ఏమవుతుంది? కరెంట్ ఇంక్రీజ్ అవుతుంది, వోల్టేజ్ డిక్రీజ్ అవుతుంది. దిస్ ఫినామినన్ కరెంట్ ఇంక్రీజ్ అయితే వోల్టేజ్ డిక్రీజ్ అయితే దిస్ కాల్డ్ యాజ్ ఎ నెగిటివ్ రెసిస్టెన్స్ రీజియన్. జనరల్గా రెసిస్టెన్స్ అంటే ఏం చెప్తున్నాం మనము? ఆర్ అంటే ఆర్ ఇజ్ ఈక్వల్ టు వి బై ఐ. Is it not? Voltage is decreased, current is increased. This value ఏమవుతుంది? Decreases, right? అదే మామూలుగా అయితే జనరల్గా అయితే ఏమవుతుంది? As voltage increases, current increases అంటే this R is equal to increases. Is it not? In this step, voltage is increasing, current is increasing. జనరల్ కరెంట్ పెరుగుతున్నప్పుడు ఏం చేయాలి? వోల్టేజ్ డ్రాప్ కూడా పెరగాలి కదా? ఒక రెసిస్టెన్స్ లో వోల్టేజ్ కరెంట్ పెరుగుతున్నప్పుడు ఫ్లో ఆఫ్ కరెంట్ రెసిస్టెన్స్ ఐ పెరిగినప్పుడు వోల్టేజ్ డ్రాప్ కూడా పెరుగుతుంది. సో అప్పుడు వి అండ్ ఐ రెండు పెరుగుతాయి. రిజల్టెంట్ ఏం కావాలి? పెరగాలి. అది యాక్చువల్గా ఉండే ప్రాసెస్ ఓమ్స్ లా ప్రకారం. రెసిస్టెన్స్ కూడా పెరగాలి. కానీ ఇక్కడ ఏమవుతుంది? వోల్టేజ్ ఇస్ డిక్రీజింగ్, కరెంట్ ఇస్ ఇంక్రీజింగ్. కాబట్టి రిజల్టెంట్ ఏమవుతుంది? రెసిస్టెన్స్ డిక్రీజ్ అవుతుంది. ఈ డిక్రీజ్ రెసిస్టెన్స్ ని మనము నెగటివ్ రెసిస్టెన్స్ అంటున్నాం. So where this negative resistance is present in this second case, then we can call this as a negative resistance region. So first region is off region or cut-off region, second region is on state or negative resistance region. After that, then when PE is more value, right? PE is equal to more and more, at maximum voltage of voltage is applied, maximum voltage is applied, right? Or we can say that when emitter current is very large, so that almost IB current flowing here is zero. Is it not? This because there is no question of any particle traveled from base 2 to base 1, right? Entirely because of this p junction. Entirely because of this p junction, because holes are diffused moving towards the base 2. Base 2 is a positive terminal. These holes are repelled from the base 2 and are moving in this direction. So no question of any base 2 particles traveling and reaching the base 1. So therefore I can say that IB2 is equal to 0. Current flowing through the base 2 is equal to 0. So at this situation, there existing a valley point, right? So this we can see in the transfer characteristics. Just I will go to the VA characteristics of UJT. So this is the cutoff state when VE is equal to no voltage is applied, or simply you can say that IE is equal to 0. Current IE is equal to 0. This is the voltage axis here, voltage, and this is current I. This current is here. I am taking current on x-axis. Be careful. The current is on x-axis. Voltage is on y-axis. Right? Voltage is taken. So when cutoff region occurs, so no question of any voltage is present. Right? So up to this region, up to this value, peak value, this is called as a cutoff region. This is cutoff region, and after this peak value, this is called as the voltage is called as a VP, peak voltage. The voltage is called as a peak voltage. So at this peak voltage, before this reaching the peak voltage, the existing voltage here, this voltage is due to the eta into VVB. This is already this is equal to N upon VA అని చెప్తాం కదా. As VE goes on increasing, when VE is equal to 0, right? When VE is equal to 0 and VE goes on increasing, or VE is less than 0, this region is called as VE is less than VP. Is it not? VE is less than VP. So this region is happened. VE అనేది less than VP అంటే VP అంటే ఏమి? Voltage across the base 1 resistance. ఆల్రెడీ VVB అప్లై చేసాం కాబట్టి బేస్ 1 వోల్టేజ్ బేస్ 1 రెసిస్టెన్స్ లో వోల్టేజ్ డ్రాప్ ఉంది, VP కదా VA, రైట్. బేస్ 1 లో వోల్టేజ్ డ్రాప్ ఉంది కాబట్టి ఆ వోల్టేజ్ డ్రాప్ ఏం చేస్తుంది? ఆల్వేస్ పిఎన్ జంక్షన్ రివర్స్ బ్యాచ్ చేస్తుంది. కాబట్టి రివర్స్ బ్యాచ్ చేస్తుంది కాబట్టి మనకు జంక్షన్ డయోడ్ కండక్ట్ కాదు, ఈవెన్ దో ద వోల్టేజ్ ఇస్ ఇంక్రీజింగ్. ఈవెన్ దో వోల్టేజ్, ఈ ఇంక్రీజ్ వోల్టేజ్ ఎందుకు వస్తుంది? VA వల్ల వస్తుంది. Is all VA voltage. So up to that point, up to this point, peak point, no question of conduction in the PN junction. After crossing this peak point, then at this point, at this region, in this region, this is VE is greater than VA. Now the VA voltage comes here. So at this region, then the diode is conducting, right? Diode is conducting, but diode ఎలా కండక్ట్ అవుతుంది? డిక్రీజ్డ్ వోల్టేజ్, డిక్రీజ్ రెసిస్టెన్స్ డిక్రీజ్ అవుతుంది, రైట్. కరెంట్ పెరుగుతుంది, వోల్టేజ్ తగ్గిపోతుంది. ఏ వోల్టేజ్? ఎమిటర్ వోల్టేజ్ తగ్గిపోతుంది. సో అంతవరకు నేను వోల్టేజ్ ఎక్కువగా ఇచ్చినా కూడా డయోడ్ కండక్ట్ కాలేదు, రివర్స్ బ్యాస్ లో ఉంది. ఎందుకు రివర్స్ బ్యాస్ లో ఉంది? VA వోల్టేజ్ అక్కడ ఉంది కాబట్టి. ఎప్పుడైతే ఆ VA వోల్టేజ్ ను VE క్రాస్ చేసిందో ఒకసారిగా ఏం చేస్తుంది? డయోడ్ కన్వర్ట్ అయిపోతుంది. అంటే రివర్స్ బ్యాస్ లో డయోడ్ స్టార్ట్స్ కన్వర్టింగ్ ఫార్వర్డ్ బ్యాస్ లోకి వెళ్ళిపోతుంది, రైట్. అర్థమవుతుందని చెప్పింది. ఇక్కడ వోల్టేజ్, ఈ వోల్టేజ్ డ్రాప్ ఇక్కడ ఎప్పుడైతే ఎక్కువగా ఉందో ఇది ఆల్వేస్ ఈ పిఎన్ జంక్షన్ రివర్స్ బ్యాస్ చేస్తూనే ఉంది, రైట్. నేను ఇక్కడ వోల్టేజ్ స్టార్ట్ చేశాను ఇవ్వడం, కానీ డయోడ్ కండక్ట్ కాలేదు, రివర్స్ బ్యాస్ లోనే ఉంది. ఎందుకు? ఎంత రోజులు రివర్స్ బ్యాస్ లో ఉంటుంది డయోడ్? వెన్ దిస్ VE is greater than this VA. VE greater than VA అయినప్పుడు ఎంత వోల్టేజ్? అది పీక్, దట్ ఈస్ కాల్డ్ యాజ్ పీక్ వోల్టేజ్. ఎంతైతే వోల్టేజ్ అప్లై చేసావు VE దాన్ని, ఆ వోల్టేజ్ పీక్ వోల్టేజ్ అంటున్నాం. ఆ పీక్ వోల్టేజ్ రీచ్ అయిన తర్వాత ఒక్కసారి డయోడ్ ఏమైంది? ఫార్వర్డ్ బ్యాస్ అయిపోయింది. ఫార్వర్డ్ బ్యాస్ అయిన తర్వాత ఇమ్మీడియట్ గా ఏమవుతుంది? ఈ ఇక్కడ ఉండే ఫార్వర్డ్ డిఫ్యూజ్ అయిన హోల్స్ అన్ని ఇలా రిఫ్లెక్ట్ అయ్యి రీచింగ్ టు ద బేస్ 1. ఈ డిఫ్యూజ్ అయినటువంటి హోల్స్ అన్ని కూడా రిపెల్డ్ ఫ్రమ్ ద బేస్ 2 అండ్ రీచింగ్ టు ద బేస్ 1. So automatically as many as the holes are reaching to the base 1, so the IE current goes on increases. As the IE current is increased, means what happened here? Suddenly this voltage is decreases. The VE voltage, ఇంత voltage అవసరం లేదు, ఇది ఆల్రెడీ కనెక్ట్ అయిపోయింది. is already conducted, right? So automatically this voltage is not necessary. When this voltage is removed or overcome, automatically the resistance is decreases. Resistance decreases automatically the voltage drop here V which are applied, that is goes on decreasing. So resistance decrease అవుతుంది, voltage decrease అవుతుంది, but current is goes on increasing in this situation. So that situation here, in that situation here, the current is resistance is decreasing and voltage is decreasing and current is increases. Current is increasing. This is the current. Exact. So this region we are calling as a negative resistance region. This region is called as a negative resistance region. Negative resistance region. So as this voltage goes on decreased and it reaches to some voltage point, minimum voltage point. This minimum voltage point I am calling as a value voltage, V suffix V. So this region we can call as simple SCR UJT is 5 on state. This is off state. This is on state, this is off state. On state means UJT is 5. When UJT is 5, negative resistance region is existing. So this fire is happened only between the peak value to the valley point. Peak voltage to the valley voltage. After reaching this valley voltage or some certain low value of voltage, if you still apply the VE voltage, then from this region, this UJT, this transistor works as a normal PN junction diode. Normal PN junction diode along the forward characteristics normal PN junction. So same thing happened here. Normal PN junction diode. Right? కొంచెం కావాలంటే స్ట్రిప్ ఇలా చూపించవచ్చు, right? So at this point, this is called as a valley point. After this valley point, then this will act as a simple PN junction diode. So from peak point to valley point, ఈ రెండు points మధ్యనే there is a special characteristics of UJT called as negative resistance region. After this valley point, if you still further increase the voltage, then the PN junction will act as a simple PN junction diode. This region is called as a saturation region. This region is called as a saturation region. So when the saturation region is reaching means there is no question of base IB2 current. IB2 becomes 0. Base to current ఏముండదు. Base to current flow కాదు. చూడండి ఇక్కడ base to current ఏముండదు. Base to current becomes totally 0 because I goes on increased. Right? So this is called as this is the characteristics of UJT. So UJT లో 3 regions వస్తాయి. One is the cutoff region, negative resistance region, and another one is the saturation region, right? So the special characteristics of this diode is this transistor is which exhibits the negative resistance region. We know already cutoff region and saturation region, but negative resistance region we don't know. So that exhibits here the UJT, right? Because of the special purpose, special characteristics of this UJT, they are existing in negative resistance. So negative resistance region means this will be exhibit between the peak voltage to the valley voltage of the emitter voltage, right? So whenever resistance goes on decreases, the voltage also, emitter voltage also decreases. At the same time, the resistance is also decreases and current is increasing, right? This phenomenon is called as the negative resistance. So based on this is the VA characteristics of UJT. So basing this concept, negative resistance concept, this best application of this UJT is best application of UJT is operating as a relaxation oscillator. This acts as a relaxation oscillator. Generally, oscillator means repeatedly coming the things, right? Oscillating between the 2 points, right? reaching the point A and again reaching the point B, and between A and B, that total is oscillating, right? Or we can say that the cycles are, number of cycles are, same cycles are repeatedly coming, right? The number of cycles in a given time is called as a frequency, right? Based on this oscillation, right? So coming to the application part here, this relaxation oscillator is constructed by. So in this relaxation, this is the construction part of a relaxation oscillator. I think this is a voltage of V naught 2 here, and this voltage here is V naught 1, right? This is the voltage generated, right? And the concept here is which is operating under peak voltage to the value voltage, peak voltage to the value voltage. So when you take the peak voltage to the value voltage, this relaxation oscillator will oscillate between these 2 points. So there is existing a oscillations, it is giving like this, right? So this is the peak voltage, and this is the value voltage, right? And the capacitor here is, the purpose of capacitor is charging and discharging here, right? Generally the capacitor is charges to a maximum voltage of peak voltage, right? Maximum voltage of peak voltage. So Vp is the peak voltage. ఎంత ఉంటుంది peak voltage ఇక్కడ? Vp is equal to this peak voltage. We are showing that eta VVV కదా, eta into VVV plus V gamma, అదే కదా. Vp is equal to VVV into eta plus V gamma. This is the peak voltage what we defined here at this point. The maximum voltage exists here. So this is the emitter voltage applied. So this peak voltage is reached here. So this capacitor charges to this peak voltage through this resistance RT. RT is the resistance. Through VVV, biasing is applied, and the capacitor initially the SCR not fires, because even though if you apply voltage VVV here, the SCR doesn't fire here, even though emitter voltage is applied, which is not in a on state. It is simply in off state. Enతవరకు how much it is the FET is UJT is in off state until the capacitor reaches to the maximum charge. So the capacitor initially charges through the RT to a maximum voltage. The maximum voltage means it is a peak voltage. So how much the peak voltage is there? Up to that peak voltage, the capacitor is charging. So under this, the capacitor charging is given here. These are all capacitor charging, right? After getting the charge fully charged, then this peak voltage will fire the UJT. according to this theory, right? Whenever the emitter voltage reaches to the peak value, right, then the UJT is fires, means switched on. UJT is switched on. So at that time it exhibits negative resistance, right? Means voltage is decreased. So the capacitor charge Vp is applied onto the emitter and UJT is fires. UJT is on. The on state is very less time. The on state of the UJT is very less time, because immediately the capacitor uh, discharges, right? So UJT on time. So this is the region, this is the period UJT is on. This is the period UJT is on. I'm not drawing the figures clearly, not good manner. Just follow this. I think you know these waveforms very well in your laboratory, right? So this is the on time. The capacitor is on up to this time, right? In this time, the capacitor discharges. Capacitor discharges through emitter to base one. Means it is fire. It is fire means it is on state. On state means it is a negative resistance region. So immediately the voltage across the capacitor decreases to the value point, right? Decreases to the value point. This value point. So immediately the on in this region UJT is on. In this state UJT is on. After crossing this voltage, then immediately the UJT is again switched off because it is reaching the value point. Then again the capacitor is charging. So capacitor discharging is through the emitter resistance R1, right? The discharging time constant is C into T1. The discharging time constant, I think you know time constant. Time constant is the tau. It is represented by, right? So C into CT into R1 discharge, and it is equal to CT into RT. This is called charging. So based on this value, how much time CT into R1, how much time it takes, at that time only this discharging is possible. Suppose for example CT value is some 1000 microfarads is only. R1 is some taking some 100 kilo. So what is the product of this? How many microseconds you are getting? Convert that, right? That much of time duration only this is on state. After collapsing that time, then immediately the UJT is off. And it goes to the charging time. Capacitor is charging again. Charging time means how much time the capacitor is charging, time period. Again, that can be obtained by CT into RT. ఈ రెండు దాంతో multiply చేయాలి. So that is the charging time constant. So based on this, the time is decided for the UJT relaxation oscillator, right? And similarly, if we measure the V02 voltage also, the V02 voltage also you can measure. V02, same potential is generated here with the same time duration. This is V02, right? This is V02. This is V01. So this is a simple example of UJT relaxation oscillator. The frequency of oscillations can be given by 1 by T, which is equal to 1 by RT, R value into CT. We'll give the charging time constant into log of 1 by 1 minus eta, right? Eta is taken as eta is equal to assumed as RB1 by RB1 plus RB2 or RBB. RB1 RB2 means resistance R1 R2, right? So like this, you can calculate the frequency of oscillation. That is one of the application for the FET. Sorry, UJT. Application for the UJT. Right. And coming to the applications of, is there any doubt up to here? Is there any doubt up to here? Are you hear me or not? Respond.
Yes, sir. Yes, sir.
So UJT ni we can operate as a relaxation oscillator ga use చేస్తున్నాం between peak value and value point మధ్యలో, right? Peak value reach అయినప్పుడు reach అయ్యేంత వరకు the capacitor, the UJT off లో ఉంటుంది. After reaching the peak point, then the UJT becomes on state లోకి వెళ్ళిపోతుంది, right? Based on that, we can calculate the frequency. So this is the VA characteristic, and this is one of the application only. And other applications of UJT are, UJT can be used as a trigger to make the trigger point, to make the trigger. Applications of UJT. Applications of UJT. One is the UJT relaxation oscillator. UJT relaxation oscillator. Second one is the to trigger the SCR. To trigger the SCR. Trigger means initiation ఇవ్వాలి. అంటే జనరల్ గా SCR turn on కావాలంటే we have to make some initiation. ఆ initiation is given by this UJT. దాన్ని ట్రిగ్గర్ చేస్తుంది. And to generate that sawtooth. Sawtooth waveform. To generate the sawtooth waveform. కదా మనకు ఆల్రెడీ చూసాం. ఎలా వస్తుంది sawtooth waveform? ఇలా వస్తుంది. So this may be further circuit is modified and reaching to ఇలా ఉంటుంది కదా మనకి, ఇలా వస్తుంది, ఇలా ఉంటుంది, ఇలా వస్తుంది. దాన్ని మనం we can convert this into the sawtooth by additional circuit. Additional circuit components you can use it and you can make this into a sawtooth. That is one of the advantage application. And fourth one is the phase control and timing circuit used as phase control and timing circuit. Timing circuits and used as a non-sinusoidal oscillator. Non-sinusoidal oscillators. So these are the different applications of UJT, right? So till now, if you have any doubts, you can raise, you can ask. This is about UJT. So once again, I will just recap the things here. UJT is a 3-terminal device, one junction device. This can be constructed by using a N-bar. On this N-bar, on one left side or right side, a P material is sandwiched or placed, so that 3 terminals can be taken out on base 1, base 2, and emitter terminal. Emitter terminal is taken at the P region, right? And to make this operation, base 1 and base 2 are applied and fixed voltage of VBB. A fixed voltage of VBB is applied between the base 1 and base 2, right? I think in laboratory we choose how much voltage you apply. 15 volts or 20 volts you can apply. Right, based on the supply voltage, there existing a potential here, right? Our voltage exhibits here because the entire N bar is divided into two resistances. One is called RB2 and RB1 here. So because of this VBB voltage, there is a voltage drop across RB1, right? This voltage variable, why I am showing means, so this center voltage after this resistance decrease poverty and variable చూపించాను ఇక్కడ. So as this voltage is voltage of across this R1 is developed, this voltage always trying to make this PN junction is reverse bias. When the PN junction is reverse bias means the UJT is in the off state, right? So to make this into the fire or on state, to make this on state, an emitter voltage is applied. As this emitter voltage goes on increasing, initially emitter voltage V is less than VA కాబట్టి it is in off state. As VE goes on increasing, at one particular point called as a peak point, VE is greater than VA. So VA, where VE is greater than VA, that point is called as a peak point. So after reaching the peak point, again the PN junction becomes converted into the forward bias. Now the holes are diffused into the N region. So this diffused holes move towards the base 2 and base 2 is connected to the positive terminal. So similar polarity, they reflect from this base 2 and moving towards the base 1. So this constitutes a current called as IE. As IE goes, as the more and more holes are diffused, right? Then this happened within the stipulated period, right? In that stipulated period, IE is very high. So because of this high current, the resistance on here, the resistance here is decreases. As the resistance is decreased means the voltage drop of the emitter is also decreases. So that can be shown in the characteristic curve. So voltage also decreases. So this decreased voltage and increased current, there existing a decreased resistance, so that is called as the negative resistance region. In this region, the UJT is 5 on state, right? So when after reaching the still V is reaching the voltage called as value point. When the V reaches the value point, then further if you increase the voltage, further you increase the emitter voltage, then the PN junction will simply works as a ordinary PN diode, ordinary PN diode. So for ordinary PN diode, the graph is the current is increases linearly, right? This is happened. This region is called as the saturation region. So cutoff region, saturation, negative resistance region, saturation. Three regions are existing. Right? Because of this negative region existing, this can be used to develop a oscillator, non-sinusoidal oscillator called as a relaxation oscillator. Right? In the relaxation oscillator, we can generate this spiral triangular form waveform. Right? So when peak value is reached, up to peak value, the capacitor is charging. When the capacitor charge is through the RT reaches to the peak value, then the emitter junction becomes forward bias. When the emitter junction becomes forward bias, then immediately the UJT is 5 or on state. So under on state, immediately the capacitor voltage decreases up to the value point. After reaching the value point, again the UJT is uh, uh, turned off. After turning off means again the capacitor is charged through the RT. After reaching again peak point, this capacitor again discharging through the base resistance RB1, through the base resistance RB1, and again the UJT is 5. This situation, and this is goes on repeating only in the negative resistance, not in the ordinary PN junction. Saturation region లో ఆపరేట్ కావట్లేదండి. This is operating in the negative resistance region. ఈ జంక్షన్ లో నెగిటివ్ రెసిస్టెన్స్ రీజియన్ లో మాత్రమే ఆపరేట్ అవుతుంది UJT. That's why we are showing the these non-sinusoidal waveforms, right? And the how much of the frequency this is repeating. So if you make some additional circuit to this one, this shape will become a sawtooth. This shape will become a sawtooth. ఇలా sawtooth గా చేయొచ్చు, రైట్? కాబట్టి దీన్ని sawtooth గా కూడా డెవలప్ చేయొచ్చు, sawtooth waveform కూడా జనరేట్ చేయొచ్చు. And how much is the frequency of oscillations is going on? Charging and discharging, charging and discharging. How much is the frequency of oscillation? This can be obtained by this formula, right? And the different applications also were covered. So this is about the UJT, unijunction transistor. And one more device in this chapter we left here is SCR. SCR, silicon control rectifier. silicon control rectifier. So this we will see next class. So there is only one topic is remaining. Silicon CR is there and one solar cell is there. So these two will cover in the Monday class. So till now, if you have any doubts, you can rise. Please ask any doubts. Pardon? Any doubts? Any doubts? No doubts?
Sir, send us recording, sir.
Recording already is there. You can go and search in the Google Drive.
Okay,
Right?
sir.
In my Google Drive, it is there already. It is stored recording. Right?
Okay.
You can download and you can play in your system
Okay.
or in your
Okay,
mobile.
sir. Thank you.
Okay, na? Right.
Okay, sir. Thank you, sir.
So if nothing else is there, then I will stop here.